So artificial intelligence. It's a term you hear literally everywhere, right? From the news to your brand new phone. But what is it, really? Over the next few minutes, we're going to cut through all the hype, we're going to demystify this massive subject, and we're going to use the core ideas from an actual university lecture to guide us. All right, so here's our game plan. First, we're going to start with the one big question that sparked this entire field. Then we'll untangle all that confusing jargon, AI, ML, DL. We'll look at why AI is suddenly blowing up right now, get real about its limits, and then we'll wrap up by tackling the big ethical questions that we're all facing.
So let's dive in right where it all started, with a single, huge, foundational question. It sounds pretty simple on the surface, but trust me, it's one that has kept scientists and philosophers arguing for, well, over 70 years.
And here it is, can machines think? I mean, this is it. This is the question. Posed way back in the 1950s, it was like the intellectual big bang for the entire field of AI. But of course, it immediately leads to an even trickier question. What do we even mean by thinking? This is where the genius Alan Turing came in. He basically said, look, let's not get bogged down trying to define the word thinking. Instead, let's create a clever, practical test. He called it the imitation game. And the idea is actually pretty simple. You have a judge who's texting with two mystery players. One's a human, one's a machine. If the machine's answers are so good that the judge can't figure out which is which, well, the machine passes.
Okay, but here's the twist. Does passing that test really mean the machine understands anything? That's the core of this brilliant counter-argument called the Chinese room. Imagine this. You've got a person locked in a room who doesn't speak a word of Chinese. They just have a giant rule book. Chinese symbols get passed under the door. They look up the right symbol to send back out based on the rules and pass it back. To someone outside, it looks like they're having a fluent conversation. But does the person in the room understand Chinese? Not at all. They're just manipulating symbols based on rules, that's syntax, with zero actual meaning, or what we call semantics.
And that brings us crashing right into today, doesn't it? When you're chatting with a large language model, is it actually understanding what you're asking? Or is it just a blindingly fast, incredibly sophisticated version of that person in the Chinese room, just following impossibly complex rules to predict the next correct word without any real comprehension? It's a really good question to think about. Okay, so with that big philosophical question floating around in our heads, let's get a bit more practical. We need to clear up the #1 point of confusion in this whole field. What's the difference between AI, machine learning, and deep learning? First up, you've got artificial intelligence, AI. Just think of this as the biggest possible circle, the giant umbrella that covers everything. It's the original, broad goal of making computers do things that seem smart, things that mimic human behavior. Now, tucked inside that big AI circle is machine learning, or ML. This is a specific approach. Instead of a programmer having to write a million lines of code for every single possibility, with ML, you just feed the computer a ton of examples, a ton of data, and it learns the patterns all by itself. It literally gets better with experience. And then we go one level deeper, inside machine learning, to deep learning. This is the real engine behind almost all the crazy breakthroughs we're seeing today. It uses these complex structures called neural networks, which are sort of inspired by the human brain. And these things are just unbelievably good at finding patterns in mountains and mountains of data. So that kind of begs the question, right? If some of these ideas have been around for decades, what happened? Why is AI suddenly everywhere? Let's look at the 3 key ingredients that finally came together to create this massive boom. The history of AI wasn't a straight line up. It was this crazy roller coaster of excitement and hype, followed by these things called AI winters, where all the funding dried up and progress just stalled out. But then, as you can see, something big happened right around 2012 that just lit a fire under the whole thing. It was basically a perfect storm. For the first time ever, 3 crucial ingredients came together. First, we got big data. The internet gave us a nearly endless supply of fuel. Second, we got powerful hardware, especially those graphics cards, or GPUs, which became the engine needed to process all that fuel. And third, we finally had smarter algorithms, better neural networks, the design that knew how to use the engine and the fuel. Okay, so now that we know how we got here, let's get our feet back on the ground and talk about what the AI we have today can actually do, because it's really important to separate what's real from what's just hype. So this right here is probably the most crucial thing to understand. Every single AI system you have ever interacted with is what we call artificial narrow intelligence, or ANI. It means it can be absolutely world-class, even superhuman, at one specific thing, like playing chess or translating French. The sci-fi dream of a machine with human-like common sense that can learn anything, that's artificial general intelligence, or AGI. And to be crystal clear, that does not exist. We are nowhere near it.
And having all this powerful but narrow intelligence brings us to our final and honestly probably our most important section, the massive ethical questions that pop up when you start weaving this technology into the fabric of our society.
As these tools get integrated into our world, we have to face some really tough challenges. For example, if you train an AI on biased data from the past, guess what? It's going to make biased decisions. Then, of course, there's job displacement, as AI starts to automate tasks that humans used to do. And maybe the weirdest one is the black box problem. What do you do when an AI gives you an answer but can't explain how it got there?
And that leaves us with one last thought to chew on. Imagine this. An AI system with a proven 99% accuracy rate says you have a serious illness. But when you ask the doctor, okay, but why does it think that? The answer is, we don't know. Should you trust it? This isn't some problem for the future. It's a dilemma that doctors and engineers are facing right now. And it perfectly captures both the incredible power and the profound challenge of artificial intelligence.